Analytical chemistry. Identification of basic radical, positive radical in a sample. Zinc and lead are amphoteric. Their oxides and hydroxides are also amphoteric. Identification of basic radical. Using sodium hydroxide solution in small quantity and then in excess. Using ammonium hydroxide in small quantity and then in excess. Why sodium hydroxide or ammonium hydroxide is used to identify basic radical? Other than NaOH and KOH, all metal hydroxides are insoluble in water. When NaOH or NH4OH reacts with metal salt solution, insoluble metal hydroxides are precipitated. Different metal hydroxide precipitates have different colors, different nature. From the color and the nature of the hydroxide, the basic radical is identified. Color of the precipitate: blue precipitate, copper hydroxide, dirty green precipitate, iron hydroxide, reddish brown precipitate, FeOH whole thrice, white precipitate, maybe calcium hydroxide, zinc hydroxide, or lead hydroxide. Why alkali used in small quantity and then in excess? It helps to identify basic radical. Some metal hydroxides are basic in nature and do not dissolve in NaOH. Some metal hydroxides are amphoteric in nature and dissolve in NaOH. Small quantity of NaOH is used to precipitate metal hydroxide. Excess amount is added to check if the precipitate dissolves or not. If amphoteric, the precipitate would dissolve like zinc hydroxide and lead hydroxide. If basic, the precipitate won't dissolve in NaOH. To distinguish between calcium ion and lead ion, colorless sample solution reacts with NaOH solution to produce white precipitate. This white precipitate can be of calcium hydroxide, zinc hydroxide, or lead hydroxide. More NaOH solution has to be added to this white precipitate. White precipitate does not dissolve and remains the same. Conclusion: white precipitate is of calcium hydroxide, therefore the sample contains calcium ion. White precipitate dissolves forming colorless solution. Conclusion: white precipitate is of zinc hydroxide or lead hydroxide, therefore the sample contains zinc ion or lead ion. To distinguish between zinc ion and lead ion, colorless sample solution reacts with NH4OH to produce white precipitate. This white precipitate can be of zinc hydroxide or lead hydroxide. More NH4OH has to be added to this white precipitate. White precipitate does not dissolve and remains the same. Conclusion: white precipitate is of lead hydroxide, therefore the sample contains Pb2 plus ion. White precipitate dissolves forming colorless solution. Conclusion: white precipitate is of zinc hydroxide, therefore the sample contains zinc ion. Identification of basic radical. Salt solution, basic solution. Copper sulfate solution, Cu2 plus ion. With little NaOH solution gives pale blue precipitate. With excess NaOH solution gives pale blue precipitate which remains insoluble. With little NH4OH solution gives pale blue precipitate. With excess NH4OH solution gives pale blue precipitate which dissolves to form inky blue solution. Salt solution, basic radical is FeSO4 solution or Fe2 plus ions. With little NaOH solution gives dirty green precipitate. With excess NaOH solution gives dirty green precipitate which remains insoluble, with little NH4OH solution gives dirty green precipitate, with excess NH4OH solution gives dirty green precipitate, which remains insoluble. Salt solution, basic radical, FeCl3 solution, Fe3 plus ion, with little NaOH solution gives reddish brown precipitate, with excess NaOH solution gives reddish brown precipitate, which remains insoluble, with little NH4OH solution gives reddish brown precipitate, with excess NH4OH solution gives reddish brown precipitate, which remains insoluble. Identification of basic radical. Salt solution, basic radical, ZnSO4 solution, Zn2 plus ion, with little NaOH solution gives deleterious white precipitate, with excess NaOH solution gives white precipitate which dissolves forming colorless solution, with little NH4OH solution gives deleterious white precipitate, with excess NH4OH solution gives white precipitate which dissolves forming colorless solution. Salt solution, basic radical, lead nitrate solution, Pb2 plus ion, gives chalky white precipitate with little NaOH solution, with excess NaOH solution, white precipitate which dissolves forming colorless solution, with little NH4OH solution gives chalky white precipitate, with excess NH4OH solution gives white precipitate which remains insoluble. Salt solution, basic radical, CaCl2 solution, Ca2 plus ion, chalky white precipitate with little NaOH solution, with excess NaOH solution, white precipitate which remains insoluble, with little NH4OH solution, no precipitate. Color of the precipitates. Blue precipitate of CuOH whole twice with little NaOH or NH4OH, inky blue solution with excess NH4OH, dirty green precipitate of FeOH whole twice with little FeOH, dirty green precipitate of FeOH whole twice with little NaOH or NH4OH, reddish brown precipitate of FeOH whole thrice with little NaOH or NH4OH. Ammonium ion. Detection of ammonium ion. NH4Cl reacts with NaOH in presence of heat to give gas X. Gas X is tested with concentrated HCl. Dense white fumes are observed. Dense white fumes are of NH4Cl. Gas X reacts with HCl to produce NH4Cl. Therefore, gas X is ammonia. Therefore, basic radical in salt is NH4 plus 1. Identification of ammonium ion. NaOH solution is added to the sample and heated. Pungent smelling gas is evolved which turns moist red litmus paper blue and gives dense white fumes with a glass rod dipped in conch HCl. The pungent smelling gas is of ammonia and the basic radical is ammonium radical. What is amphoteric? Substance that reacts with both acid and alkali. Zinc, lead and aluminium are amphoteric metals. Their oxides are amphoteric, their hydroxides are amphoteric. Amphoteric metal reacts with alkali to produce hydrogen. Zinc reacts with NaOH to produce Na2ZnO2 and hydrogen. Aluminium reacts with NaOH and water to produce NaAlO2 and hydrogen. Lead reacts with NaOH to produce Na2PbO2 and hydrogen. Their oxides reacts with alkali to produce salt and water. ZnO reacts with NaOH to produce Na2ZnO2 and water. Al2O3 reacts with NaOH to produce NaAlO2 and water. PbO reacts with NaOH to produce Na2PbO2 and water. Zinc hydroxide reacts with NaOH to produce Na2ZnO2 and water. Aluminium hydroxide reacts with NaOH to produce NaAlO2 and water. Lead hydroxide reacts with NaOH to produce Na2PbO2 and 2 molecules of water.